Hi, teacher. My name is Ana Sofia, and I'm gonna explain my procedures for the exercises in the evidence. So, in the first problem, in the first exercise, it asks us the force between the charges, and they give us that it is a sphere, that they are spheres, that the charge of one is 3 times 10 to the minus 6, and the distance, which is 0.1 meters. So what I did was I took the force formula and I substituted and I put the data in there, and then I got force equals to 8.0.8 newtons. And because they are both positive and they both repel charge or energy, they are rejecting each other. If one were to be positive and the other one negative, then they would attract each other, but since they're the same, they reject. In the second one, I only got the first part of it, which is A, and I got that 1 mole equals to 63.54 grams on Google, and we have that the mass is 18 grams, the distance is 5 meters, and then I did a rule of 3, that's how you say that in English, and I put if 1 mole equals to 63.54 grams, then how many moles are 18 grams? And I got the moles, and then I also got that 1 mole equals to 6.022 times 10 times to the 23 ATM. And then I did the same, a rule of 3, which is 0.24 moles equals to X ATM, and 1 mole equals to 6.022 times 10 to the 23. And then I did another rule of 3, and I had that 1 atom equals to 29 electrons, so 1.68 times 10 times 23 atoms equals to X electrons, and then I got 4.87 times 10 to the 23, and that was half of my second problem. In the third problem, we have a charge, we have force, and it asks us the electric field. So with the electric field formula, I put charge over force and got I put force over charge and divided them, and then I got that the electric field equals to 200 newtons over coulombs. And in the fourth problem, it gives us velocity. It asks us the electric field, the direction, it gives us the distance, and it asks us the time. So I use the formula for electric field equals to K times charge over distance square, and I substituted everything and got the electric field, which was minus 0.00000183 newtons over coulomb, and I got that in a formula, distance equals velocity times time. So I substituted things, and then I got time, which was 0.028 over 3.75 times 10 to the 6th, and got that 9 seconds, which is a weird number. It's very weird. It's probably wrong. but I got 0.000000007 seconds, and that was my answer. And in the G problem, it gives us the electric field, it asks us the work, and it gives us as well, I think the charge. I think it's the charge. I didn't really, the distance, and I think the charge. So I used the formula for, what was it? Potential energy, which is the same to work. And did 5 times 10 to the minus 6 times 5 times 10 to the 4 times 0.05 equals to 0.0125 joules of work. And then in the E was very crazy. I didn't understand the E entirely, and Saul explained it to me, kind of, but I didn't fully understand him, so this is what I understood of him, which I hope is right. So we have that the Gauss law equals to Q over epsilon 0, and I put a little note on that exercise that if it sounds the same, which it probably does, it's not because I copied him. It wasn't the A. It was just it's just that he explained it to me, and I wrote what I listened, so it's probably the same, but it's not the A. So he explained to me that since we're calculating an enclosed sphere, that the charges are uniform, and with the Gauss law we kind of combine it with the electric field force, and because of the area, because if it's a sphere, we get that electric field equals to Q over 4 times P epsilon 0 times radius squared, because also that's the formula of the electric field of a sphere. And that yeah, those were the ones that I did. And I don't know if I don't think I have to explain the first 3 problems. Well, no, the first part. Okay, no, ignore me by this point. So thank you, teacher. Bye. Please give me a 100 and please pass me, because you're a very cool teacher and I really want to pass physics, and I really need to pass physics because I need to graduate, and I am fearing for my graduation because of physics. So please pass me. Please put me on 100. And I hope you have a very good trip and good life over Switzerland, maybe. Well, thank you, teacher. Goodbye.